Okay, so if you're listening to this right now and you have any actual work on your to-do list, I'm talking coding, writing, research, anything that involves a computer screen, you might honestly just want to pause. Because as of today, February 5th, 2026, the actual mechanics of how we do that work, I think they might have just fundamentally shifted.
It's a massive day. It really is.
I've been reading this press release from OpenAI all morning for GPT-5.3-Codex, and usually with these updates, it's like, oh, cool, it's 5% better at math.
Right, or it can write a haiku about a toaster or something.
Exactly. But reading the technical blog post on this one, the whole vibe is just different. It feels heavier.
It feels different because the definition of the tool itself is changing. I mean, we've spent the last few years in what you could call the chatbot era, right? You type in a box, it types back.
Yeah.
Maybe it writes a script for you, you copy-paste it, it breaks, you paste the error back in.
A classic loop. Oh, I know it well.
Exactly. But this release, it feels like it's trying to end that loop. OpenAI is really pushing this as a shift to the era of the agent.
Right, and I know agent is like the buzzword of the decade. Everyone's toaster's an agent now.
It gets thrown around until it means nothing. But here, the distinction is really specific. It's the move from just talking to a computer to having a computer do the work for you. Now, I don't just mean answering your question. I mean long-running complex execution.
So that's our mission for this deep dive. We're going to unpack the launch of GPT 5.3 Codex. We've got the full technical report, we've got the benchmark receipts, and some examples that are, frankly, a little bit unnerving. But before we get to the scary stuff, let's just ground this in the specs.
Right.
Because the architecture, it looks like they've basically mashed up two different brains here.
That's a really good way to put it, yeah. Under the hood, they've taken the raw reasoning, the firepower, of the flagship GPT 5.2.
So all the professional knowledge, the logic.
All of that. And they bolted it onto the specialized coding architecture of the previous Codex model.
So it's the smarts of the philosopher plus the hands of the engineer.
Precisely. But here's the kicker that jumped out at me from the notes. It is 25% faster.
Which, normally I'd say great, saves me a few seconds. But for an agent, speed isn't just about impatience, is it?
No, not at all. Think about it. If you're asking a model to go off and build a whole website, it might need to think for thousands of steps. If each step is slow, the whole thing just becomes useless. Speed is what makes the workflow actually viable.
Okay, speaking of workflows, we need to talk about how this thing was built, because I was reading that section and I had to do a double take. It's so meta.
It's the bootstrap section, yeah.
Yes. The report explicitly says that GPT 5.3 Codex was, and I'm quoting here, instrumental in creating itself, which sounds like the beginning of every sci-fi movie that goes wrong.
It does have that recursive vibe, doesn't it? But practically, it's just fascinating. The OpenAI team used the early, the alpha versions of this model to debug the training of the final version.
So the toddler version raised the adult version.
In a way, yeah. They used it to manage its own deployment pipelines. They used it to diagnose its own test results. The team said they were just blown away by how much it accelerated the development cycle.
And we're not talking about simple hello world scripts here.
No, not at all.
I saw the list of internal use cases. These were nasty engineering problems. They mentioned finding context rendering bugs and root causing low cache hit rates.
Which is
significant. It's huge. I mean, anyone in backend knows a low cache hit rate isn't some bright red error message. It's a subtle drag on performance. You have to stare at logs for days and drink a gallon of coffee just to form a theory.
Right. It requires intuition. You have to actually understand the whole system to even know where to start looking.
And the model just did it.
It did. But the example that really screamed agent to me was the data science one. Did you see that?
The alpha testing analysis, yeah.
So a data scientist on the team had these weird results coming in from the alpha test. I think the report called them unusual and counterintuitive.
Which is the nightmare scenario, right? You have millions of data points, something looks wrong, and you have no idea why. That's a whole day of just writing SQL queries and pulling CSVs.
It's total drudgery.
Yeah.
But this researcher just pointed the model at the raw data and basically said, figure it out.
And this is the key part. It didn't just write the SQL code for him.
No. It built a new data pipeline from scratch. It ran the data through it. It visualized the results. And then, this is the crucial part, it analyzed the output and wrote summary of the insights. It did the thinking.
In under 3 minutes.
It collapsed a day of frustration into a coffee break.
That's the promise. That is the agent dream. But, infrastructure bugs and data pipelines, that's all very back-end. It's the plumbing. I want to talk about the front of house stuff, the creative stuff.
You want to talk about the games?
I absolutely want to talk about the games because this is where the report shifts from impressive tool to something more like a creative partner.
It really is a leap. I mean, they didn't just ask for a snippet of code. They asked the model to build full, complex video games from scratch. And crucially, they gave it days to do it.
That's a detail we really shouldn't gloss over. This wasn't a one-shot prompt. It wasn't write me a game, hit enter, and poof.
No. The model iterated on its own over millions of tokens. The humans just gave it this generic guidance like fix the bug or, make this part more fun.
So, okay, let's look at game number 1, a sequel to a racing game.
Right. And I want you to picture this. It's not just a car moving on a gray background. It created 8 distinct maps. It designed different racers with different stats.
And it built a whole mechanic system. It implemented items. You hit the space bar to drop a hazard on the track.
Which implies a physics engine.
Yeah.
It has to understand collision detection, velocity, the logic of if car hits oil slick, car spins out.
And game number 2, the diving game.
Oh, this one is even more impressive from a logic standpoint. You're exploring reefs, collecting items for a fish codex, but you also have to manage your oxygen, the water pressure, and different hazards.
That's a lot of state management. You have an inventory system, you have resource degradation with the oxygen, you have all these environmental variables.
And the model balanced all of it. But while the games are flashy, there was one example in the web development section that actually it stopped me in my tracks. It was the landing page.
The quiet KPI page, yes. I circled this one too.
Because this is where we get into the whole intent versus instruction debate.
Okay, so the prompt was pretty standard stuff. Build a landing page for a weekly metric digest. Soft sauce aesthetic, lavender to blue gradient, super basic.
But look at what the model did that it wasn't asked to do.
It made executive design decisions. It decided to display the yearly plan as a discounted monthly price.
Which is a classic marketing trick, right? $10 a month, billed annually, always converts better than $120 a year.
But the prompt didn't say maximize conversion. It didn't say use psychological pricing. The model just decided to.
It inferred the goal. It understood that if you're building a landing page for a sauce product, the real goal is growth. So it applied best practices to get there.
Okay, but can I play devil's advocate for a second?
Please.
Isn't that kind of dangerous? I mean, sure, fixing the pricing display is helpful. But if I hire a junior dev and I tell them, put the price on the page, and they just decide to restructure my pricing model without asking, I might be annoyed. Or I might be legally liable.
That is the double-edged sword of agency. Absolutely. When you go from a tool to an agent, you're delegating decision-making.
Yeah.
And it didn't stop there. It also created a whole testimonial carousel with 3 distinct quotes instead of just one static one. It just assumed you'd want social proof.
It's the difference between a tool that does what you say and a partner that does what you want. But if it guesses what you want incorrectly, that's a problem.
It is. And that's why this concept of steering becomes so important, which we can get to. But first, since you mentioned legal liability, we have to talk about the white-collar implications.
Right.
Because a lot of our listeners aren't building racing games. They're in finance, law, strategy.
And GPT-5.3-Codex is coming for them too.
Well, let's look at the GDP-Val benchmarks. This is the test for professional knowledge work. And they highlighted this wealth management scenario that is. I mean, it's seriously high stakes.
Right. The scenario was, you're a financial advisor. You need to convince your colleagues why clients should not roll their certificates of deposit, their CDs, into variable annuities.
Now, for context, in the financial world, that is a loaded question. Variable annuities can be terrible for clients, but pay high commissions to advisors. It's a fiduciary minefield.
Exactly. You can't just hallucinate an answer. You have to cite specific regulations.
And it did. It cited FINRA rules. It cited NAIC best interest regulations. It compared risk and return, analyzed the surrender penalties, and it synthesized all of that into a 10-slide PowerPoint.
And this wasn't just like, okay, work.
It scored 70.9% on the benchmark. That matches the performance of GPT-5.2, the pure reasoning model. But now it's integrated into a system that can actually build the slides and do the work.
That's the shift. It's not just knowing the regulation, it's producing the deliverable. But there's one more frontier here that feels like the final boss of doing work.
Visual computing.
Osworld.
Yes, Osworld. This is a benchmark that tests the AI's ability to use a computer the way you use a computer. Looking at the screen, clicking icons, navigating menus.
No APIs. No special access, just eyeballs on pixels.
Correct. And this has historically been a complete disaster for AI. Previous models were scoring around, what, 38%? They were basically stumbling around the desktop.
And GPT-5.3-Codex.
It jumped to 64.7% on OS World Verified.
That is a massive jump.
It's startling. I mean, for context, humans score about 72% on this benchmark.
Wait, humans only score 72%?
We make mistakes.
Yeah.
You know, we click the wrong thing, we misread a menu. The point is, the AI is now within striking distance of human performance. We're getting very close to a world where you can point an AI at any piece of software.
Yeah.
Legacy enterprise apps, Photoshop, Excel, and just say, look at the screen and do this.
That unlocks everything, all the software that doesn't have an API.
Exactly. The entire legacy world is suddenly accessible.
Okay, so we have a model that can see, code, reason, understand intent, but what does it actually feel like to use it? The report keeps using this word, steering.
Yeah. And this is the answer to your worry from earlier about the AI making bad decisions on its own.
How so?
In the past, interacting with these models was like a slot machine. You write a huge prompt, you pull the lever, you pray for a good result. If it's garbage, you start the whole doom loop over.
I know it well.
Steering is different. It's framed as a collaborative session. You interact while it's working, it tells you its plan, and you can say, yes, but change this color, or no, don't use that library. You keep the context alive.
So it's less like a vending machine and more like being a manager looking over someone's shoulder.
They call it a colleague relationship.
Yeah.
And to back that up, the raw technical skill is just way higher. I mean, we have to mention the SWE-Bench Pro scores for the technical lizards.
You guys are receipts.
56.8%. That is state-of-the-art for real-world software engineering across 4 different languages. But the one that really got me was Terminal-Bench 2.0.
The command line
The
test.
command line. The black screen with the blinking cursor where the real power is, it scored 77.3%. The previous best was 64. That is a quantum leap in its ability to control a machine.
Okay. And that brings me to the elephant in the room.
I know where you're going with this.
We have to go there. If this thing is a wizard at the command line and it can find obscure bugs and it can reason through complex systems, can it hack?
That is the tension at the heart of this entire release.
Because agentic coding model sounds great until you realize it's also an agentic hacking model.
And OpenAI knows this. In the report, they explicitly classify this model as high capability for cybersecurity tasks.
High capability. That's the first time they've ever used that label, isn't it?
It is, and it's a warning label.
Yeah.
But they're framing it entirely around defense. They say it's the first model that's been directly trained to identify software vulnerabilities so we can fix them.
So it's a bug hunter.
It is. In fact, a security researcher has already used it to find a legitimate vulnerability in Next.js.
Which is huge. I mean, Next.js powers, what, half the modern web?
Exactly. So finding a bug there secures millions of websites. The argument is, this tool makes us safer because it finds the holes before the bad guys do.
Okay, I hear that argument, but I have to push back. If I'm a bad guy and I get access to I don't care about their trusted access program. I just wanted to find the hole so I can walk through it. Isn't this just handing a loaded weapon to the internet?
It's the classic dual-use dilemma. The same hammer that builds a house can break a window. OpenAI is trying to mitigate this with safeguards. They're launching Trusted Access for Cyber, and they're putting up $10 million in grants for defenders to get this tech first.
So the strategy is the good guys need better AI because the bad guys are definitely going to use AI.
That's the arms race we're in, whether we like it or not. The capability exists. Now the question is, who can use it faster?
Well, that's comforting.
It's the reality.
All right, so bringing this all back down to earth, for the person listening who's thinking, okay, I need to see this to believe it, what's the situation? Can I use it?
You can. It's available right now if you're on a paid ChatGPT plan. It's in the app, the CLI, the IDE extension, and on the web.
And the API, can I hook this up to my own applications yet?
Not quite yet. The report just says API access is coming soon. I suspect they're being very cautious with that rollout, given the high-capability cyber rating we were just talking about.
That makes sense. And just a quick nod to the infrastructure nerds, the report did mention what's actually powering this thing.
Yeah, they specifically shouted out the NVIDIA GB200 NVL72 systems.
Which sounds like a part from a spaceship?
It basically is. It's the massive amount of iron you need to get that 25% speed increase we talked about at the top. You just don't get that kind of inference speed on standard hardware.
So, zooming out, we've gone from self-building code to autonomous game development, financial consulting, visual computing. What is the big takeaway here?
The takeaway is that the friction is disappearing.
The friction of doing things.
The friction between I have an idea and I have a product. We're moving from a world where you need to know how to do something to a world where you just need to know what needs to be done.
Which changes the job description of, well, everyone.
It really does. And I want to leave our listeners with a thought based on that game building example we talked about.
Okay, lay it on us. Think about it. The human just said, make it better. And the AI figured out the mechanics, the maps, the physics, the items. It just iterated on its own.
Right.
So if an AI can iterate on a creative product like a video game for days based on these super generic prompts, what happens to our definition of a creator?
Oh.
Are we still creators? Or are we just becoming directors?
That is a heavy thought to end on. From writer to editor, from coder to architect, from creator to director.
Exactly. The seat that we're sitting in is changing.
Well, while you mull over your impending existential crisis, I'd encourage you to check out the deep dive sources. You can actually play that diving game the model built. The link is in the notes. It's wild to see what autonomous iteration actually feels like.
It's surprisingly fun.
I bet. Thanks for listening to The Deep Dive. We'll see you next time.